before we start, as usual, like please sign in so that we can record that you're actually being a member so you can vote later. Another thing I wanted to mention is that coming up in October, we're gonna have the security career fair. So I'm gonna start posting links to a form where you can upload your resume, and next week we'll have it up on the presentation. So if you're interested in getting, a role in security in a company, that's what the security career fair is for. It's not the same thing as the CSC career fair, obviously, since it's happening in October and not at the end of September. So more info about that will come in soon. And before we start, we have some stuff on mentorship as well. I forgot you had a thing.
Hey guys, so I'm going to be running the mentorship program this semester. Today is the first day that our applications are open. So last week we dropped the interest form, but now this is the link to the actual application. It'll be open about 2 weeks, and it's just getting some general information about yourself, your personal interests, and then your interest within security. After the 2 weeks are up, we plan to start doing the matching process. So I think around maybe like the end of October when the career fair is starting, when you maybe want your resume reviewed or you want just like practice for like one-on-ones and elevator pitches and stuff, then we'll get you with your matches then. Thank you.
I think that's it. If everyone already signed in, anyone that just came in, then you can sign in using the QR code. It helps out because that's like how we get like payment and stuff. So it's like really helpful if you sign in. I know you signed in. So this presentation is going to be very introductory. It's going to be for people with very little experience. So if you've already done stuff in Linux or with the CLI, then this might be redundant, but I'm still going to introduce some resources and stuff that you can use that will hopefully still be helpful to you, even if you have experience. But yeah, let's start with what Linux is. So it's an operating system like Windows and Mac. And specifically, Linux refers to the kernel of what is more technically known as the Linux GNU operating system, with GNU being the tools and the programs that actually let you use the system, because the kernel by itself doesn't have any of that. A command line interface is a text-based interface for running applications, unlike a graphical interface. And this is how people used to use the computer. Everyone used to use it like this, and it's less popular now, but programmers and security researchers will still use it like this because it's definitely more efficient than using a GUI in some cases. CLI applications are controlled through commands, and you supply arguments to those commands. So an example of this would be if you wanted to run ls, I think this first one's a typo here, but the second one, if you wanted to run ls, which is a command used for showing files, you could run arguments -al, and that would let you, view more files. If you run the ls command by itself, then it'll act differently. And we're gonna get into this because I actually have a server set up for everyone to be able to run these commands. There's a lot of common arguments for CLI tools. -v usually means show the version or show more logging, be more verbose. -h will usually show like a help message, and -c will usually be used for supplying configuration. There's some basic CLI utilities here that are going to be really helpful for when you are working in Linux. pwd shows you where you are in the file system. ls will show you the contents of the file system and wherever you are. cd will let you change to different places. Touch will let you make files. Makedir will let you make directories or folders, as they're called in Windows. Move will let you move directories and files from place to place. And it will also let you rename files by moving them from their original name to a new name. And chmod will let you change permissions on files. So that's helpful. So you're probably already familiar with like files and directories. And again, like I said, directories are also called like folders in Windows, but it's basically the same in Linux. There's not much of a difference there. But what is important in Linux is the concept of permissions. There's three different types of permissions. The first is the permissions that apply to the owner. Next is the permissions that apply to the group. And then finally, the permissions that apply to everyone else. So I have an example here of a file. The file's name is test. And the first three things that are listed here are the permissions, the owner of the file, and the group owner of the file. So the file is called test. The group is student. The owner is me, Jack. And the permissions are listed here in this format, with the first three letters being the permissions for the owner, the next three being the permissions for the group, and the last three being the permissions for everyone else. And these permissions say that Jack has the ability to read and write, the group student has the ability to read, and everyone else has the ability to read as well. If you had, like, for example, if test was a program instead of like a text file, you would also have to have an additional permission set here called the executable permission. And if that permission isn't set, you can't run that file as a program, which is important. There's a couple of special paths when you're using Linux. A dot will refer to the current directory that you're in. Two dots will refer to the parent directory of where you are. Slash is the root, which is the highest up you can go in the file system. And a tilde will represent your home directory, which is like where all of your user files will go. There's this other concept that's really important called environment variables. And these are variables that you can set in the context of a specific process, which is usually going to be like the terminal that you're in, the shell that you're running. And this basically just lets you share information and persist information without having to use, like program-specific variables or anything like that. And we're going to get into how that works as well pretty soon. Next thing is piping. So when you run a program, you'll often be outputting some kind of data, or you're going to want to take some input. And what a pipe lets you do is it provides you with an interface to direct the information. So you can direct where the information's going to or where it's coming from. Input and output streams are file representations of the input and output of a terminal. So you may have seen this if you've taken a programming class. You may have seen like standard in, standard out. In Linux, these are actually like files. They're special files. And an example of how you can use the echo command with a pipe and one of these files is what this would do, this command, is it would just echo a smiley face to the special device null, and that would cause your output to just go into the void and it would just go nowhere. And finally, there's SSH and SCP, and these are what we're going to use right now in order to try out all these concepts. SSH stands for secure shell, and it allows you to connect to a machine over a network securely. And SCP is a very similar tool, except instead of giving you a terminal, it'll let you copy files between machines. So I just went over a lot. Yeah. So SCP stands for secure copy, and it's an older program. And I believe it's like not really recommended to use anymore. SFTP is just a more feature-rich version of that command. Oh yeah, just stop it. Yeah. So does anyone have any questions up to this point? Because right now I've just kind of gone over some of the concepts, and they might not make a lot of sense without using them, but we're going to do some exercises now and actually like use them and try them out. So are there any questions up to this point? Okay, is everyone logged into a machine? Because we're going to run the following commands in a command prompt. So if you're on a Windows machine, then what you're going to do is hit the Windows key and then type CMD, and that'll open a terminal for you. And then we're going to wait for everyone to do that and then do the next step, which is SSHing into this server, this Linux server. Yeah.
You have to be on desktop?
No, you just have to be on UF's Wi-Fi. Okay. So I'm going to wait for everyone to do that. And then I'm actually also going to do that. Let me get my terminal up. So I'm going to do it in here just to also show you guys, but it should be pretty easy to do. So I'm going to do SSH. I'll make this bigger first. I'll make this bigger. That's better. All right, so I'm typing in SSH mygatorlink at ufsit.cic.ufl.edu. And you log in with your Gatorlink password. If I can type it right. Okay. So once we're logged in, this is a Linux server. It's running something called Ubuntu 2004. And you can do pretty much anything on here. Of course, you're not allowed to do suspicious activities, but we're gonna use it to run some of the commands and concepts that I went over. First thing we're gonna do is we're going to print text and use environment variables. So in the terminal, if you type, yeah, so Jeff just sent a message to me because you can do that as well. How do I scroll? What just happened to my terminal? Huh? Oh, okay. When I hit enter, it like messes up. Yes, this is true. So let me restart it then, because that's easier. Wow, why is that so messed up? All right, I'm just gonna use it like that. All right, so first thing we're gonna do is we're gonna use the echo command. We're not using CMD, this is horrible, it's not working. We're using PuTTY. Change that, make it a little bit bigger. Okay. Okay, so we're going to use the echo command to say hello. That's pretty easy. We're also going to use an environment variable here to demonstrate how environment variables work. So I'm going to define a variable called test var. And the way that you do that is just by listing the variable, putting an equal sign, and then the quotes are optional, but it makes things easier and you can put whatever you want in there. So I'm gonna say, hello world. And I actually have to prefix this with something that I forgot to mention, which is export. And that will make it available for all commands that I run after this one. So now if I do echo test, if I put a $, that's how you signify that you're getting the value of the variable. Echo $test var, then that works. If I do something like this, so if I was to say like new test var, and I said this is new, and then I tried to echo that, it also works. So it turns out export isn't really necessary, but yeah. So that is the echo command. Those are environment variables. Now we're going to navigate the file system. So if you want to see what's in your current directory, you can do that with ls. and you can see that I have a file in there called test. I'm going to supply some arguments to this command because I want to see more information. So I'm going to do ls-l, and that will show all these extra attributes like I had shown before. For you guys, it's probably going to be empty. And so in order to have a file in there, we're going to use the touch command. So if I do touch test, or actually I already have test. So let's do touch test new. And then I run ls again. And the way that I'm scrolling through these commands is by using the up and down arrows, because it's easier to use the arrows rather than to try to type stuff in again. So you can see that the file was created. And if I wanted to make a directory, instead of touch, I would use mkdir, which is going to make a new directory. Okay. If I want to go to that directory, I use cd. And then I can also look at what's in here, and it should be empty. And I'm going to make a file in here as well. Yep. If I were to supply another argument to the ls command, -a, you'll see two more things will pop up in here. And these are those special directories that I had been mentioning before. So dot refers to where we are right now. And when you do -a, it just explicitly shows the dot and the double dot. If I were to do cd to dot, nothing will change because I'm changing to where I am already. If I were to do cd to dot dot, then you'll see that I go back up to the directory that I was in before. If I did that again, then it's going to take me even farther. And if you do it enough times, eventually you end up just not going anywhere. You end up at the root directory, which is as far as you can go. If I use the tilde, that'll take me back home. And if I run pwd, that'll show you explicitly where you are exactly. If you've noticed on the left here, you'll actually see the directory that you're in. And it will shorten your home directory to that tilde. But if you do pwd, then it will show you exactly where that tilde is, because it might change from system to system. One more important thing is that you'll notice that when I do ls-l, I have 3 files in here, or 2 files in a directory. But if I do ls-la, you'll see a lot of other stuff in here. And the reason that you don't see those files when you run ls by itself is because the dot in the front, basically the ls command will ignore those files when it's listing out files. And we can actually make our own hidden file if we just add a dot to the file name. So if I do dot catch me if you can, and if I run ls, you'll see that it doesn't show up. But if I run ls-la, it does show up right here. Yeah. Are there any questions so far? Can't really see above the monitor, but if you do have questions, then feel free. I thought that you had to in order for it to work, but you don't. That was useless. Yeah, you can just define the variable in the shell. What exporting will do is it will make it available to, I believe, other processes instead of just the one that you're in right now. No, it won't keep it. I don't think. Yeah. So what we're going to do now is we're going to change the permissions of an existing file. So let's, you can use the clear command and that will, clear everything away like that. It's not necessary, but it makes things easier. Let's look at what we have in here first. So we have some files. I'm going to change the permissions of this test file. So I don't want everyone to be able to read it. I only want myself to be able to read it. So in order to do that, I'm going to do G to specify group, and then I'm going to write a minus to specify that I'm removing permissions, and then I'm going to specify R. to specify that I want to remove the read permission for the group that's associated with that file. And if I look at that file, you can see that I removed that permission. Yes. Yes, so for directories, the X means that you can traverse that directory. So when you, I think an example would make it most clear. So I'm gonna make a new directory, I'm gonna call it test. Test exec. So I have this new directory test exec. And you'll notice that it's readable and it's executable to everyone. If I were to change the permissions of this folder for myself and I were to remove the executable bit from it, u-x, yeah, test exec. If I remove the executable bit from that file, you can see that I still have the read permission on it right here. I'm able to read and write it. But if I try to go into it, I can't. Even though I can read it, I can't go into it. And that's because there's a difference between being able to be in a directory and being able to read from that directory. The reason that that difference is important is because if I make this executable again so I can use it, if I go into here and I make, for example, let's make a file. And I'm going to add some text to that file real quick. So if I remove the executable bit from it, again, test exec, and I try to cat that file, it won't work. But if I then, add it, u plus x test exec, it will work. But you'll notice that if I remove the read permission for the directory is test exec, and then I try to cat that file, it still works. I don't have read permission for that directory, but I can still read the file in it. And the reason for that is because the executable bit is set, which means that I can traverse it and then get to the file that I do have permissions to read. The reason that's useful is because you might have other stuff in that directory that's sensitive and that you don't want people to be able to read. But maybe you do have certain files in there that they can read, and that's why that's useful. Yeah. I hope that answered the question. So that's about it when it comes to files and permissions. I might have gone a little bit quick, so if there are any questions, then asking is good. Yes.
How do you delete, like, you do RM to like delete files?
Yes.
How do you delete the one that you did?
Delete the one that I
The one
hid.
that you did, like, touch dot, that you delete.
Oh, okay, yeah, okay, exactly. So let's actually get into removing files right now because that's a good point. So if I want to get rid of a file, then the command to do that is rm. So if I do rm test, test is gone. He was asking, okay, now how do you remove the hidden one? Because it doesn't show up here anymore. Well, just because it doesn't show up when I ls doesn't mean it's not actually there. It is there. It's called .catch me if you can. And you can remove it like any other file. And if I have to do LA to show that it's actually not there anymore. So the dot doesn't mean that the file has any kind of special hiddenness. It just means that when you run ls, it's not going to show up. But the file is still there. I think in Windows, a hidden file is like special. I don't know if it's the same or not, but yeah, adding the dot, that's a convention of the ls command that it won't show up like that. But similarly, you can remove directories using a different command called rmdir. And if I do it on new dir, it won't work because there's stuff in there. And that's good because using rmdir to remove empty directories is usually good for not accidentally destroying information. If I make another one real quick, so I'm making a directory called remove me, and then if I do rmdir on that directory, so you can see remove me is there. If I do rmdir on remove me, that works and it's gone. In order to remove nudir, I can either remove the files in it and then remove it, or you can do something else, which is use the rm command and specify some arguments to it. I'm going to say -r, and that means recurse into nudir, and that will delete nudir. You'll often see people run rm as like rm-rf, and then the directory. F means force, and that's scary, and that can cause destruction. So it's better to usually either use rmdir or use rm-r. And if you have protected files, then it'll let you know that you can't just do that, and you can't just destroy stuff. If you decided that you typed in a command and that you didn't actually want to run that command, like I have this tested out and I'm like, oh, I don't want to, run that. You can either, you can delete the command using backspace, or you can abort by doing Control-C. Works the same as when you're doing, when you're running a command and it's active, Control-C will kill that command. So if I was, I don't know, what would an example of that command be? I don't know, we'll get into that later. So that is the file system. Those are permissions, and that is how you manipulate files in the file system. I don't think I missed anything. So any questions? That should be complete. Okay. Now we're going to look for patterns in a file. So this is one of the more common things that happens when you're using Linux. I specifically use it a lot. And in order to do this, we're going to use a tool called grep. So grep stands for, I think, grab regular expression. I think, what does it stand for? GNU regular expression parser. Yes, because it has to be complicated. So this command will let you specify three things. It'll, the first thing is the command itself. The second thing is the pattern you're looking for. And the third thing is a list of files that you want to search for that pattern in. So to show an example, I'm going to make a new file and I'm going to call it grepme. And in here, I'm going to do this. If that will copy paste, that might have been a bad idea. It's funny, that's why. Okay, so I have this file with some content in it, and I want to search for an expression in that file. So I'm going to say grep, let's see, what's a word that might show up in here? Let's do B. So I'm going to say grep for B in grepme. Again, these parentheses that are the quotation marks that I put around B aren't necessary, but I usually do it to be explicit because you might have other weird things in those parentheses as you use more advanced concepts. So it shows me all the lines that have the word B. And it's really powerful to be able to do that. You can also specify -r, that will do a recursive grep. And if I do grep-r for ufsit in the etc directory, and I run this as root, oh, I can't run it as root. Well, if I just ignore the errors and just look at where it does show up, you'll see it'll show me all the places recursively in etsy where it shows up. So I didn't specify this file as an argument, but because I said -r and I gave etsy as the directory, it will just go through all the files it can find in that directory and show me all the matches. So it was in two places, machine info and host name. And then all these errors are because I'm running as a normal user and there's certain things you can't access as a normal user. So that's grepping. Are there any questions? Yes.
How would you make the errors go away if, say, there were so many errors that it filled up your entire screen?
Yes. Good point. So when I run this, there's so many errors here, and it's kind of hard to see what the results actually are because there's just all these permission denieds. The way that we can get rid of those errors, and this is true for all commands that you run in a terminal, we can do a thing called, I don't know exactly what it's called, but you can essentially redirect standard error to, some trash output. So if I say, I think it's 2 greater than dev null, right? This basically says, okay, this 2 greater than says redirect standard error. Oh, I didn't do anything. Okay. Yeah. Okay. So this 2 greater than says, okay, take standard error and just like put it in null. Like, I don't really care about that anymore. You can do the same thing with 1. And what that will do is that will take the standard output instead of standard error. Let me clean this up so it's easy to see. You can see that when I pipe 1 to dev null, it gets rid of the actual matches, but it leaves the errors. When I do 2, it gets rid of the errors and leaves just the matches. This works for any command. If you put this at the end of any command, it will output its error output to nowhere. Yes, and that's touching on a concept which is, like we had said before, piping. That's what this is. And piping takes many different forms in the terminal. This is one of them. So now we're going to look at how piping works for files. So if I use my echo command, okay, so I'm going to say echo pipe me, and I use an arrow without any number in front of it, and then I specify the name, the destination, and for the destination I'm going to say pipe destination. If I do that, then you'll notice that a new file exists called pipe destination, and I haven't mentioned this command yet, but there's a command called cat, which will let me view the contents of this file, pipe dest, and you'll see that it has the contents of this echo statement that we did up here. You can also use 2 arrows, and instead of piping what you said straight into the file, and that's exactly what's being piped there, it will append what you piped to that file. If you didn't do that, and you just used a single arrow, it'll override everything in that file. So single arrow will pipe exactly what you gave it to that file, overriding anything that's already there. A double arrow will append the information that you gave it to that file. And that can be pretty important because if you use this and you don't mean to, you can destroy stuff very quickly. You can also pipe information from one command to another command. And to demonstrate that, I'm going to type a couple of sentences. Let's see. This is my first sentence. Look here a second. Okay, so if I pipe this, I'm using a vertical bar to pipe to a command instead of a file. If I pipe this to the grep command and I grep for second, you'll see that it did something similar to what happened when we grepped the file, which is it actually, is highlighting where that match was. And this is pretty useful, especially when you combine it with using existing files. Something that you might do a lot. Let's see, if I take grepme, for example. The way that we used grep before is we said grep e grepme, right? So this is the file that we're grepping, this is the expression, and then it'll show you the matches. You could also do it a second way, which is you can cat grepme, which will, output the entire file like that. And then you can pipe that into grep and then grep for the matches. And you might ask, well, okay, if we can just specify the file name as one of the arguments, then why would we cat the file into the command? And the reason that it's really useful to be able to do this is because we might be getting our information not from a file, but from another command. Like maybe, I think curl is one of them. If you're like trying to get information from the internet, you can essentially pipe that information from the internet straight into grep, and you wouldn't have to save it to a file or do anything else. You can, if you think about it, you can think about how this would be really flexible, and you can do a lot with this. Are there any questions? Piping. Yes, I'll actually go ahead and give an example of that to make it clear. So if I think of a file that I have, let's see. I know that I have this as a file. So this is my website. This is a file that I have on my website. I'm going to download this using a curl command, and curl is a command that basically says, hey, here's this link, download that link. If I do that, it'll do what cat does, except it does it for internet links. So this happens to be kind of like a little like resume, but using curl, I can then pipe that output into grep and then maybe just search for where my name shows up. So you can see, so this stuff is actually like some extra information that curl gives you, but down here is the output of the grep command, which shows you where my name shows up in that file. Yes. Does that answer your question? Yeah. Okay.
Recording is on. If you want, so we still have like 2 boxes. So
yes.
Go ahead and grab things and napkins.
Yeah, so we just did piping between applications, and now we're going to make a shell script. So we've been writing all these commands out in the terminal. We've been typing them. You could also maybe copy paste them. But what a lot of people end up doing when you have lots of commands that you want to run in sequence is you'll use a shell script. Before we do the shell script, I want to introduce another tool called Nano. This will get me in trouble because a lot of people have opinions about Nano. I like it. So if you type in Nano and then the name of a file that you want to create, so I'm saying nano test.sh, this is a text editor, and this will let you, hang on, my phone is, yeah. Okay, yeah, well, okay, I'm gonna wait for the displays to stop being weird. Okay. So in Nano, we can do anything that we could do in another text editor, right? So I'm going to say, type out some of the commands that we've been doing. And maybe do echo pipe into pipe dest. I'm going to do maybe ls-l, and then I'm going to, you know, I'm not going to exit. I'm just going to leave it at that. So this is a basic shell script that will do all these commands that I just ran. And it's pretty much the same format as the format that you would use in the terminal. You separate commands by making, hitting enter and having a new line. One of the differences with a shell script is that it's not strictly necessary, but usually a good idea to add what's called a shebang in the front. And the shebang starts with a pound and an exclamation point, and then you write the path to the interpreter that you want to use. Oh, yeah. Yeah. So you then will specify the path to the interpreter that you want to use, which is usually something like bin sh or bin bash. So the way that we exit nano is by doing Control X. It says, do you want to save it? Yes. Name of the file, test, enter. That's fine. And then we can look at that file, test.sh. Okay, great, we have it. In order to run it, you can do it a couple of different ways. One of the ways is by typing in the name of the interpreter, bash, and then the name of the file, test.sh. So it printed out hello world. It echoed something to pipe des, pipe, and then it did an ls. And it did all of that at once, instead of us having to type each of those things in one by one. You can also run it directly. And the way that you would do that is by typing in /test.sh. But it's not executable. These are the permissions that we were talking about before. So it has to be executable. chmod plus x. I'm not going to put a U or a G or an O because I just want it to be executable for anyone. And then the name of the file. It's executable, and ls, when it's executable, will change the color to make that clear. Now, if I try to run it, it does work. The reason that you use a // and then the name of the file, rather than just specifying the name of the file like that, is because there are programs on the computer. Okay. There are programs on the computer that are stored in different locations. And if you don't specify manually the location of where you are, which dot being the current directory and / just being showing that you're specifying stuff in the directory rather than a file with a dot at the beginning of the name. This tells the computer explicitly, hey, I want to run the file that's in this directory. If you don't specify // it's going to say test.sh. Okay. Is that in /bin? Is it in /user bin? Is it in /user local bin? It's going to look in all these different places, and then it won't find it, and it'll say, okay, I couldn't find it. One of the places it won't look is where you are right now. So that's why you have to do // and it does have to be executable if you're running it like that. Yeah. So any questions? Yes. You can, yes. So in order to do if statements, it's similar to normal if statements, but they look like this. So this is the format of an if statement in Bash. I'm going to get rid of this stuff so that it's clear what's running right now. So an if statement takes the following format. You say if, and then you have to specify square brackets, and then you put a semicolon after that. Then all the stuff you want to run, and then feed. And feed terminates it. Yep. We run that. It works. If I were to say if not true, right, which is false, it won't run that. It won't be output. I think another thing that's a little bit important to note is that there are also conditionals that you can use in the terminal and in shell scripts. And just for reference, anything you can do in the terminal, you can do in a shell script. And anything you can do in a shell script, you can do in a terminal, and it's a little bit harder to do in the terminal because you have to type out all the formatting, the spacing, the semicolons, all of that. But they are the same thing. They're, you know, it's the same interpreter. You're running the same commands, the same syntax. One of the things that you can do instead of doing what I did here is you can do this: true and echo truth. So what happened there is that I ran the true command. This is actually a command, okay, that returns a true value. If that command is true, double and means basically continue only if the last command was true and run the next command after the double and. You can do something similar, which is you can do an or. Oops, I'm going to do that. So an or will operate in a different way, meaning if the first command executed successfully, I'm putting that up to make it obvious. Okay, that was weird. So what this says is it says if this command executes successfully, or this is what it does. It says only if the last command did not execute successfully should the next command run. That's what the double bar means. So I think another word that these are referred to as are as like short circuits, meaning the and says only continue if the last thing was true, and or means only continue if the last thing wasn't true. You can accomplish something similar by just negating the first command, but this is very, very much easier to do, just specifying those double bars. So those are a little bit more advanced concepts, but they're also interesting. Okay, so finally, we are going to use the SCP command, and we're going to copy files to and from our remote server. So I'm going to close out of here, and I'm going to open up CMD, and I'm going to use, instead of SSH, I'm going to use SCP. SCP stands for secure copy, and it works very similar to the copy and move commands that you can run otherwise, except it works over a network. So I'm going to copy, I have a file that I had put on the server actually, under this path, srv presentation.pdf. It's a PDF of this presentation. So if I do SCP, my username at the server, and then I specify colon to say, all right, anything after the colon, this is the path to the file. That's my, so my first argument is SCP, that's the command. Second argument is, it's basically, it's kind of like a URL, I guess. The first thing is your username. Second thing is the server that you're connecting to. And the third thing is the path on that server that you're copying. The third argument is going to be, where do you want it saved? I'm going to say I want it saved right here where I am. That's dot. Log in. It copies. I do a, not an ls because Windows doesn't have ls. I do a dir, and there's the file. You can also copy files to the server. And I'm not going to do that because I don't like the Windows terminal, but you could do that. I mean, we could actually do that with just the presentation. So I'm going to copy the presentation back to the server. Except I'm going to copy it to my home directory, which I can do like that, or I can do like this. They're the same thing. It's just one is a shortcut for the other. And if I SSH to the server, buddy, LS, there it is, presentation.pdf. I copied that there. Yes. Any questions? Any at all on SCP?
So the question is why use over, so why bother using like SFTP?
You should use SFTP. So SCP is a simpler command because I believe it existed before SFTP, but SFTP is more feature rich, and I believe SCP is not really like supported or maintained anymore. They operate, it's the same syntax. You could replace SCP with SFTP and it would accomplish the same thing. Yes, yeah, so SCP uses SSH, SFTP uses SFTP. You know. Oh, SCP uses SFTP. Oh, I thought it used SSH. Okay, yeah. But yeah, better to use SFTP most of the time. And I'm going to throw in a little bonus here. We've gone over a lot of like basic concepts, but if you're interested in having a little bit more swag in your terminal, then you can use something called tmux. And if you noticed while we were using this terminal, we can only do one thing at a time. And in the case of Windows and most other computers, you can usually have multiple windows open, and that's really helpful. But in order to do that in a terminal, we use something called tmux. And tmux stands for terminal multiplexer, and it adds this little bar on the bottom here that acts as kind of a like tab pane. It'll show you all the different tabs that you have open. So I have one tab open right now, and I can do stuff in here, right? And if I write a little code here, this is going to run forever. It's just going to keep printing hello. And let's make it a little bit faster. So this is going to run forever, and I don't want it to stop. So the way that I would, start another process is by first doing Control B and then C. That created a new tab down here. And I can do stuff in this tab. What can I do in this tab? I don't. I can't install it. Let's just do something similar. So I can do whatever I want here. And then if I want to go back to my other one, I do Control B key, which means previous. If I want to go back, Control B key. So I can switch between these. And the way that you can detach it is by doing Control B D. And then I can reattach by doing tmux attach. And all my stuff is still here, even though it went away. I can even detach, disconnect, reconnect. And then if I do tmux attach, it's still there, even though I disconnected from the server, it's still running. So that's nice, and that's really convenient at times. You get rid of it by killing, there's a couple ways you can get rid of it. The way that's most common is by typing exit in that tab and then typing exit in that tab. You just kill all of the tabs that you made, and then once there's no tabs left, it destroys itself. Yeah. And tmux is pretty new. I think it was made in like 2012 or maybe around that time. The way that people used to do things is with screen and with jobs. And I always prefer to use tmux. Those other things have their place, and you can still use them, but tmux is pretty popular and very, very useful. That's it. Those are the basics. If there are any questions, then do feel free. This server will stay up. I don't know for how long, but you can also feel free to just, connect to it and try out anything you want to try out that isn't destructive or like, invasive. And yeah, that's it.